Hello and welcome back. Today we're going to look at target 1B, which is I can rewrite expressions involving radical and rational exponents using properties of exponents. Our MLO is I can convert between expressions involving rational exponents and radicals using properties of exponents. So this first part here is intended for you to kind of see what's happening. It's an investigation. And so we're asking you to evaluate the following with a calculator. So I encourage you to pause this video and to plug each of these values in the chart into a calculator and see what you get. So pause the video now. All right, so now we're going to take a look here. You should have seen that square root of 25, or should have known that is 5, and 25 raised to the 1/2 power is also 5. The fifth root of 243 is equal to 3, and 243 raised to the 1/5 power is also 3. The square root of 4 raised to the 5th power is equal to 32, and 4 raised to the 5/2 power is also equal to 32. And you should start to see a pattern here. Cubed root of 8, all raised to the 5th power, is 32. And 8 raised to the 5/3 power is equal to 32. So what's happening here is we're just taking this term and rewriting it into this term. So we're taking the cubed root, which becomes the denominator of the exponent, raised to the 5th power, which becomes the numerator of the exponent. So let's take a look down here at rewriting from radical form to rational or exponential form. So here we have the root. Well, I should start with, let me start with the base. The base always goes right here. Okay, the base is the same here. So you will still keep the same base. The root, so like the square root, the root here, will be the denominator of the exponent. And then the exponent that's underneath the root, or it could also be on the outside here, will be on the numerator. The numerator of the exponent. So that is the general form for our rewriting. That's the general form for rewriting of this. You have let's see, it's not written here. You have this thing should be written a to the p over r is equal to r square root of a to the p, which is also the same thing as parentheses, the root of a raised, that whole thing raised to the p power. Here's what I was looking for. This box is what you should have on yours. And this right here is the rational exponent form. And these two forms is radical form. Remember, radical is just another term for, like, we typically call a square root. That's what we're used to seeing. But radical is the same thing as that root there. Okay, so we're going to look at radical to rational exponents. Exponents is the numerator and the root is the denominator. So in example 1 here, we have the 10th root raised to the 3rd power. But when nothing is written here, it means the square root of 10. So I would write that 2 in. So base is 10, so we rewrite 10. The 3 is the exponent, so that's the top of our fraction. The 2, the square root, that's the bottom of our fraction, so 10 to the 3/2 power. Here, 2 is our base. This is, nothing's written for the exponent, so it's a 1, so 1 over, and then 6, which comes from right here. So 2 to the 1/6 power. Example 3. Our base is 2, so we keep the base 2 raised to the 5/4 power. Here we have 4 raised to the 1 power, d raised to the 5th power, and the whole cubed root of that. So we look at each base separately. So our 4 has an exponent of 1, and then that radical is 3. So we write that as 4 to the 1/3 power. D, 5 will be the top of the exponent, and 3, again, will be the denominator of the exponent. So there's our final answer there. Example 5, our root is 7, or our base, sorry, is 7x. And since this whole thing is being raised to the 3rd power, you could write that as the 4th root of 7x, all raised to the 3rd. Remember, that's the same thing. So then this 3 will be the numerator of our exponent, and the 4 will be the denominator. And then I forgot to put parentheses there. That's important there. So the 7x, that whole thing is being raised to the 3/4 power. Example 6. 2, since there's no parentheses here, we have 2 different bases. So 2, which is to the 1st power, since nothing is written, a to the 3rd power. Okay? There is no root, so we write in a 2. It's the square root of 2 to the 1st, a to the 3rd. This 5 is just a coefficient, so you're just going to write it out here, and it's just kind of along for the ride there. Okay? It doesn't have anything to do with the root or that exponent right now. So then, I do have multiplied by 2, which is this base, raised to the 1/2 power. Okay, and then we have base of a, which is raised to the, let me switch colors here, 3/2 power. And that's our final answer. I'm going to circle here. All right, rational exponents to radicals. So numerator becomes the exponent, denominator becomes root. So we're just going the opposite way. So 7 to the 1/2 power. Okay, the top number, the 1, sorry, I should back up. The base was 7. So 7 is what's going to be underneath the root. The 1, since it's on top, that will be the exponent, so raised to the 1 power. And the 2, since it's the denominator, it becomes the root there. So the square root of 7 to the 1st power, which typically we just write that as square root of 7. If I can circle that. Square root of 7. There we go. Here, 4 is our base. So we write 4. We write the root sign. Try that again. There we go. 2 is the top, so that's the exponent. 3 is the denominator, so that's the root. So the cube root of 4 squared. Now we start to have some variables. So a is our root. So we write a, and we write the roots, and it's the cubed root raised to the 5th power. Now, this example, the parentheses indicates that this whole thing is going to be under that root sign. So we need to write 5x as the base. We write our root sign. The top number, 5, is the exponent that goes outside there. And the 4 is the denominator, so it becomes the base. And that is our final answer. Number 11, notice that there are no parentheses, so the only thing being raised to the 1/3 power is the x. So the 5 is just a coefficient that goes right along with it, and the x is the only base. So that's the only thing that we apply the root sign to. The 1 is the number on the numerator, so that will go out here as the exponent. And then the 3 is the denominator, so that will be the 3rd root. 3rd root there. So 5 times the 3rd root of x, so just make this look nice. 5 cubed root of x. For 12, lots of things going on. First of all, notice that this is all just multiplication. We have 6 times x to the 7/4 times 2 times x to the 4th. So the first thing I'm going to do is take the coefficient, 6 and 2, and pull those out front, because that's where we write them. So 6 times 2. And then I have this x to the 7/4 and x to the 4th power. Remember, when we are multiplying variables that have the same base, we write the base again and we add the exponent. So then we're going to take 7/4 plus 4. So 6 times 2 is 12. X, 7/4 plus 7/4 plus 4 is 23/4. Okay, and we want to take this 23/4 as the exponent. We want to write it like a radical. Okay, that's our directions here. So finally, we want to write 12, which stays. The x is the only thing being raised to the exponent, so it's going to go underneath the radical there. 23 out here, and 4 is the root. And that is your final answer. Last two examples. Again, everything is just being multiplied together. So I'm going to take the coefficients 4 and 2, pull them out front, and multiply them together. Now I notice that bases are the same, x and x. So I'm going to still multiply, I'm going to keep that same base, and that means I add the exponent. So 3 plus 1/3. 4 times 2 is 8. X raised to the 10/3 power after you add this. After you add the exponents here. 3 plus 1/2. This would become 9/3. So 9 plus 1 is I get the 10, and then still over 3. Anyway, we want to get rid of this here. So we are going to write this as 8. X is the base, the only thing being multiplied by the 10/3. So then the 3 is the root, and the 10 is the exponent. Lastly, 6 times 7. Pull that out front. Bases are the same, so we keep the same base. We add the exponent. 6 times 7 is 42. X times x still, raised to the 11/2 power. We want to get rid of this fraction in the exponent, so we write 42. X is in the radical. It's a square. square root raised to the 11th power. And then we typically write this as 42 square root of x to the 11th power.